Guys, this video is a batch of interesting information that you probably never seen before. I will now explain what subjects will be covered in this video, and then I will include the material without recorded without a script, as well as this introduction. I will put time codes in the description so you can jump on the subject you are interested about, but then I don't guarantee that you will understand all things without a context. So first of all, of course, the main subject of this video is a testing of the real true capacity of this battery. It's the old battery, it says 75 amperes hours, but we don't have that capacity there anymore. It's very old, and the main subject is the test, and the test, according to a standard C20, C5, what these numbers means. Also reserve capacity at 25 amperes. What are all these numbers and what standards cover them? It's all in my first episode. Watch there. Without this you probably don't understand this video. And during this test a lot of different strange things will begin, and I will cover then specific of this electronic load. For example, why it shows overpower when we don't increase the current that is here. It stays 30 amps, but why it shows overpower? Yeah, that's important. You will see it here. The test will be with this rig that I designed. Check the episode number 2 about this rig, about part numbers and specific of that one. But here you will see a specific of a software of this Victron SmartShunt and convenience of using this software, especially for monitoring discharging, maybe charging too, but mainly for discharging monitoring. And then we discharge this battery to total 0, absolutely discharge, and the video will be converted to testing of this Victron charger about how it's handled to charge deeply discharged batteries, 0-volt batteries. And actually it will go to the episode number 3, so not in this video, but some parts will be covered here. Though in the episode 3 you will see how it works, clicks, noisy, different kind of stuff, but finally the battery is charged or not. Watch the episode number 3. And then we analyzed the discharge profile using this shunt and software inside of the battery, and we will understand, the most important, we will understand why it's important to have a kind of SOC monitor, state of the charge monitor, instead just a simple voltmeter. And you will understand then when you buy this monitor and when you have the old battery, you cannot set 75 amperes, for example. You cannot set this capacity in the setting of your shunt. That's the very important part. Well, and as the result of everything, we will finally find out the real capacity of this battery, and we'll test it again according to the standard. So a lot of information and a lot of things to discuss in comments, especially by experts. Let's start. Now I have quite old BOSCH battery, 75 amperes hours. You can see it is on the charging, the load is disconnected, and we can see it's in the absorption stage, 1.9 amperes, and shunt shows pretty the same value. The charging is completed, and I disconnected, but not the battery, but the charger, because when you have a battery monitor, you have to provide power to this monitor all the time. So in ideal situation, you don't disconnect the battery. It consumes just a few milliamperes, so it's not a problem, it's fine. And so yeah, I disconnected the charger, and in the app we can see that is, but I didn't disconnect it from the power, so that's why we still see this charger here, like in a storage mode, and we can see the amount of energy we provided to this battery. It was almost charged before, so it's not much. And here on the shunt we can see like the current voltage and state of the charge, and it should sit 24 hours before we start to provide the load to it, but it's okay to my experiment that it sits for 12 hours. Anyway, it's not a perfect standard that we test, but quite close to it. So now we will provide the load. For the load, I decided to go straight away with 25 amperes. So I set the range here because you have option 5 amperes and 30 amperes. It is about the tolerance, but for us it's fine. So I said 30 and here 25 amps and constant current. I don't describe this equipment a lot, so we will discharge it with 25 amperes using the method of reserve capacity, because I want to know quick the result. It's actually the first time I use this rig. I don't know how I will edit my videos, but that will be the first time with this battery. I don't want to use this 20 hours C20 method, not the standard but the method, because I will need to wait, and guys, I don't like to wait before I will burn something here. So you can see unflammable materials all around here, but I want to test the rig for 25 amperes while I'm here in my garage. So when I click this on, it will start draw the current from the battery. I will connect and let's go to see what happens. Well guys, let's pretend that I'm not so stupid, and let's convert this part of the video to the question why I see overpower message on my Siglent unit if the current is not exceeded the rated current 30 amperes. Guys, it's not 100 volts and 30 amperes that you can test. It's 200 watts that you can test with this load. 12 multiplied 25, we are well over 200 watts, and that's why you see this message. Oh yes, okay. We don't test 25 amperes. I cannot test. So yeah, that's true that I called this toy in the beginning. It is a toy. I cannot test according to the standard about reserve capacity. Unfortunately, nothing. I realized just with you, because I don't use any scripts, guys, and I honestly show you this information, and I hope you appreciate it with your like, subscription and some comments. So guys, the only option to test is to use another method that we can that is how to call this, known for us, using this. Yeah, so C20. So we 75 we divide by 20, we get the current. I will check it soon. I will take my calculator on my PC, and then we set that current, and definitely we will be within 200 watts then, and that's the only option to test this battery then. So why do you see this message overpower on your Siglent unit? Because you increase the power that is rated for 200 watts, multiply your voltage 2 amperes and see what is the real power, and stay within this power. I think it's quite good without a script. So, well, I got the current with quite difficult math. Yeah. Okay, and we are discharging the battery. We're discharging already a couple minutes with this current, perfect current set, constant current, no problems. So, and we have voltage drop, so we see the power. We can see the same numbers on the shunt here, yeah, but the most interesting part will be here in trans, where ADC of this shunt, that's our main, actually, our main monitor, our main item in this test, because the load can be different, but that's the main item in this test. And ADC, built-in ADC, they provide here quite interesting chart. They will be more interesting over the time later. We will see them. We are waiting before we get 10.5 volts according to standard. We don't wait 20 hours. We are waiting for 10.5 volts, because this is what says in the standard that I probably covered or will cover somewhere. I don't know, because I don't use script, so I don't know how I will edit this video. We will see 10.5 here. If the battery is new, it should happen after 20 hours or more, but not less. But it's not new, it will happen probably early, but I hope I will still be able to sleep. And we start the test in 6 p.m. so it's also quite convenient to check what time it will take. But anyway, we will see it there on the chart in trends. Yeah, so I hope no bad things will happen during this time. It's a small current, really small, so no heat here on the wires that are designed for 30 amperes. But anyway, for a better sleep. I bought this unit many years ago, I don't remember how many, more than 5, and at that time I was need to use this for low power, low voltage, low current. I probably never thought that I will be testing automotive batteries, so if you consider to buy a kind of this unit now, I would suggest to look for 400 watts, then you are covered for the tests of automotive batteries. Yeah, guys, you can actually buy some kind of junk on AliExpress for about 150-200 bucks, 400 load. It will work somehow, definitely better than just halogen lamps or any other load. If you consider a more professional unit, let's say, well, so-called, then you can watch Siglent, Rigel, I don't know how you pronounce them. Maybe even that kind of O1 or something like that. Yeah, these brands. But keep in mind about the total power. Probably you never thought about it like me many years ago when I bought it. So 9 p.m., 3 hours later, we see that picture. I don't say is it good or bad, just that picture. 12 volts, about 12 volts. Well, let's say 12 volts. This is the resistance. It should actually, so we are discharging. It should fall down, yeah, because it increases when the battery is charged, right? Right or not? Well, 9 p.m. Let's see what will happen tomorrow morning. That's what we see on the next day. The shunt is shut off. I think everything is bad. As the result of the situation, I started to test this charger for its ability to charge, totally discharge 0 volts battery, and this video is in the episode number 3. So I splitted them, otherwise it would be quite a long video, this one. The shunt cannot start yet, yeah, from this voltage, so we cannot check what was the history there when we reached 10.5 and when the battery shut off. Well, it shows state of the charge 42%. I configure it to remember state of the charge when the power is lost. Well, actually, so I don't know what the number it is. We see like consumed 44. Well, yeah, we don't know, but we will see soon. And we see this voltage here, the same here, current. So the charger provides and the shunt shows this current. Well, the most interesting is inside. We see two notifications here, but they are about now, so it's the time that is now. We don't see any historical notifications, so we don't know. And now the most interesting will be on the chart. Guys, first I thought that it lost all data and doesn't store this in EEPROM, a non-volatile memory. I'm not sure how it's right on English, but no, it's just about the time when it lost power. It was about 5 a.m. when I was in deep sleep. So we should figure out the right scale and see what has happened. Here was an icon and I click it and here that information. I don't want to meditate about it right now, but I show this on the screen because I don't know if I will see it again. Okay, I will. It's here. And I think it's the same information. So something about lost the time. So let's just try to analyze. Guys, I found the starting point. Before that I told probably wrong things. I don't know if I will put them to this video, but that was the start point, 6 p.m. yesterday. So we ignore this alarm, not alarms but warnings, because they don't affect us. So, and it was like charging there, shunt configuration. So the start point was here. We started to discharge this battery, and now look what is happening. Yeah, so yeah, the crucial moment is somewhere here. It shows 57% of the capacity, but we know that it is not true because it's not 75 amps per hours anymore. We know this because it didn't withstand 20 hours on the test. 20 hours is not yet passed since 6 p.m. yesterday, and also the battery is old, so I expected the problems, but not so huge, but they are. So about 2:40 a.m. we have that point when things become problematic, and then they become even worse quite quickly. Probably one of the cell is disconnected, 3.10, and then we have the shunt shut down because of the low voltage, which is probably 5 for this shunt. I don't know. It says like it was 43% of the capacity, which is not true, and it happened 5:30 a.m. So we definitely don't have 75 amperes hours here, but we will know how much we have. And how we will know this? According to standard. Watch the part about the standard. If you don't know why we do this, the capacity is measured until we see 10.5 cut off voltage on the terminal. So it's about somewhere here. Yeah, it's quite difficult to get it. Wait a moment. Okay, I got it. So it shows 56 capacity, but it's 0 according to the method of the test, and it happens in 2:50 AM, which means about 9 hours. 9 hours to reach 10.5, not 20 hours. So if we multiply 9 hours to the current 3.75, we get about 33 amperes hours capacity. So the real capacity, we cannot say reserve capacity because we didn't test with 25 amperes. Probably we can, I don't know. But the real capacity is 33 now. I hope you understood how we got it. So using this shunt, that's why it's quite a good method. We can see the history. We can see when we drop to 10.5, we have timeline, which in that case remained correct, and we ignore the state of the charge. Actually, the math will match because so for 9 hours, if 100 is 75 amperes hours, it says like 56 we have, and we have actually 0 at that point. It's 10.5 volts, which means that it's about half of real capacity, and 33 is about half, so it matches. So guys, what we need to do now with that battery, if it will be charged, and it seems that the charger is doing job well, it will. I hope, I don't know if it will be restored well. Yeah, so we can see it's that voltage there. The charger does the job and recondition. So we will need to set this battery in the settings of the shunt not as 75 amperes hours, but as 33, which is real capacity, and then we should monitor the half 50% of state of the charge with that new capacity. Yeah, so we should consider this battery as 33 amperes hours, and we actually can figure out where this will happen at about 75% of current scale, let's say. Do you understand why? Yeah, because 100% we said is 75. We got about half capacity of that, so half of half. I just didn't change settings yet. Will be somewhere here, and let's take a look. It's about 11 p.m., which means from 6 p.m. 5 hours. Yeah, 5, about half of 9. Yeah. So, and the voltage, this voltage is quite close to the one where you should shut down the battery. Yeah. So the battery will give about 4 of this battery probably will, I don't know, 4 or 5 hours of power, and that's it. That's when you should cut off it. Yeah. That's why it's good to have in your real installation, like I have in the board, some kind of monitor that will monitor state of the charge. You don't treat the battery just by the voltage, but the best by the state of but the monitoring, and cut off at half percent. But you cannot set 75. You cannot set true written capacity of the battery of the old battery in your monitor. You got the point, yeah? So you buy the new monitor, you take the old battery, you set it. No, it will be totally wrong. So the battery is charged, and video about this experience of charging totally zero battery by this charger will be published in already published in the previous episode, I think, number 3, so you can watch there. You can watch in the description, you will find the links. And now I will synchronize this shunt while it's still there on the charging in the storage mode. I will set the current stayed as 100%, but our new capacity will be, as we found out, 33 amperes hours. So 33 amperes hours will be our new 100%. I will do this, and then I think we continue the test with the new numbers. Okay, as you have seen, I synchronized the shunt, set the new capacity. We can see it's solid now, solid blue. And I was attempting to check the process of charging here on the charge, and I'm quite not quite sure why is this strange scale. Probably when I set the new capacity and new 100%, it's also transfer this information to this chart somehow, and it becomes broken. But doesn't matter. We are not so keen about charging process here. And the discharging process we watched previously, yeah? So in this video. And the charging process and stage and time we can see in the history of the charger. And as I told, this is in the previous episode number 3. Well, actually, when I exited to this menu from the shunt menu, it's blinking again. And honestly, I was lazy to research in the documentation like the average user the blinking of these LEDs. So if you know, let me know in comments. I believe that it's solid only when I am inside the menu, because I was thinking that it's solid when it's synchronized and blinking when it's discharging. I don't know, let me know in comments. I disconnected this from the charging, and by the science we have to wait about 1 day for chemistry inside to equalize, let's say. I don't know if this is the English definition, so but I'm very lazy guy. I don't like to wait, so because if we wait, now it's midday, so if we wait, we need to test with C20 method again. Watch the first episode if you don't understand why. We need to test with the current 165 new current, and we need to test 20 hours, which again lead us to the night, to safety issues, etc. So I don't want this, and we tested until it reached 10.5, which is theoretically 0 amperes hours for the numbers written on the battery. That's why I will be testing with C5 method. Why C5? Well, I just want C5 here on the optimal battery. C5, for example, 50 hours. You can decide any C. In that case, the current will be 6.6 amperes. Yeah, Picasso is still doesn't work his job well. So 6.6 amperes, and I want to test with the higher current here, yeah, to make the test of my rig with a little bit higher current. And 5 hours then more or less acceptable to wait, because I can also wait an hour or two without charging this, and then start this test. And assumably we will reach 10.5 with this current in 5 hours. Let's see. 2 p.m. and we are ready to start the test. 6.6 amperes are set. Here we just click on and we start this test, assumably 5 hours. So here we are interested only in this screen. Yeah, so some remaining time. That's quite strange. Okay. So state of the charge. Yeah, so here we have this constant current that will be 6.6, and we expect that it will be enough for 5 hours. But let's see what will really it gives us. According to the standard, we should see this 10.5 on the terminals of the battery. Again, watch the first episode to understand it. That's why I decided to connect voltmeter to the terminal of the battery. But first I wanted to check that measurements from this voltmeter are similar. 1249 to that one, 1246 more or less. So I'm going to connect it there and let's see. Okay, it's connected there and we see a little bit more. 1258 in compare with this one, of course, because we have a voltage drop on that line, and according to standard we need to control 10.5 there on the terminal. So let's wait. I decided to make a trick to set low state of the charge alarm to 50 so that we have the time of this event, because this 50 threshold is interesting for us because that's the minimum to which we can discharge, not when we test it, but in real life, these kinds of batteries. This 50 threshold is interesting for us because then it shows us for how long we can use this old battery in real life scenario. And by the way, this current 6.6 amperes, more or less good for power radio and fridge in the board, but we don't want to use this in the board anymore despite of this symbol here. So but still it's quite good for the testing this value, and then we need to stop discharging at this voltage, not like the previous time when we left it for a night, because every of these tests hurt the battery and we don't want to do this many times, probably just one time, and that's why for the future I plan probably to design an update of my rig with use of this monitor of the load from Victron again, or probably, I don't know, I never needed here is an option probably to set disconnection of the load when the voltage drops to a specific value. I don't know, probably here. I have some other options, but probably I will use this one, so subscribe to see update of this rig. And now let's just wait. So 1 hour and 14 minutes since we start discharge it, and it shows that the remaining time is 34 minutes. I am not sure what exactly is this number. It doesn't match. It seems it doesn't match with things that we have. So we set 33 AH capacity. It's now 66. Is it till set threshold of 50% or till 0? Not sure actually. So yeah, but let's wait. And while we still discharging this, I decided to use this scanner. So we have about, it says 15 minutes, 57%. It's definitely about 50%, I think. So I decided to use this scanner to check the temperature in Celsius again. Sorry guys from the US. So, but what we see here on the fuse, we see around 25 Celsius, so not much. The charger doesn't take part in this job, So the battery is really cold with discharging by 6 amperes, 6.6, and the tool, the load is about 30, and the hot air blows here about, you can see, 45 degrees Celsius here. So that's the situation here. What is there? What is there? What is that one? Probably a cat was here. Okay guys, we are approaching 0 remaining time and 50% state of charge. So definitely this setting is related to the alarm that I set there. So remaining time till the set alarm. So, and we want it not to be less than 50, and we will see it soon. And actually it's just 1 hour 45 minutes since we started the test, so we will not get 33 amperes hours with this current. Yeah, so I'm not sure that we will get with that one. And guys, I think you can make some conclusions yourself already, but let's wait just a couple minutes and do some conclusions. Well, we got the alarm. It was 5 minutes ago when I recorded another language. So let's just fix the numbers. 12, 16 here, 12, 13 it says here, and 12, 24 on the terminals of the battery. It's already 48%. So we consume 12 amperes hours. I don't believe we have 33 with this current, but we, I think, still should wait for 10.5 to see here and see again. But guys, it's a kind of a loop, you understand. And probably now the most important point. Yeah, I think I covered it already, either in this video or another episode. You cannot just take the old battery and set 75 amperes hours there. We set it now 33, yeah, you can see. And for just 1 hour 50 minutes we consumed 12 amperes hours, and it is 50% of the state of the charge. How to explain this to you? It's quite difficult to explain. Yeah, so we are trying to find the new capacity, then we're trying to test with another current, with a high current. We have again some other number we will have probably. So it's a kind of loop. That's why it's quite interesting to test with the new battery. When we take absolutely new battery, and I think it's coming in the next episode, subscribe, to test C5, for example, with 10 amperes current. My electronic load will manage this for 15 hours, for 50 amperes hours, yeah, and see how it does with the new battery. But once again, the shunt is good, and probably not the shunt, but battery monitor is good and probably must have. But in case of old batteries, you cannot just keep it. The real capacity of the original capacity of the battery is 100 capacity in the shunt settings, and I think when batteries are aging, they aging fast. You need all the time to adjust these numbers, and it's quite difficult to figure out them without testing till 10.5, and you cannot test it every time. You cannot do these tests. So if you set 75 amperes hours in your shunt settings couple years ago, and you still keep it, and you still rely that 50% is your threshold, then it's not good, because in fact you discharge it more then below the 50% of the new capacity, which is reduced after the time. I think that's the main subject of this video. I think that's the main message to you. I don't know if you have seen this kind of stuff anywhere else. If not, then like. Yeah, but let's wait till we see 10.5 as set in the standard on the terminals of the battery, and then we will get again some numbers and let's see what they are. So guys, now after about 2, 3, 4, 5, 6, after about 4 hours, I see quite a strange picture. State of charge shows 0 when we consumed only 25 amperes hours, not 33. We don't care about the voltage because the voltage that we are expecting is not related with any of these settings. We just expect this voltage. I hope you understand what I mean. But these numbers are quite strange because we said that our 100% capacity is 33, if you remember here, 33 amperes hours. So I'm not sure why when we consumed 25 it shows 0. So if you know, let me know in the comments. I honestly don't know. And you know, Victron doesn't provide any support. It's the company that says that dealers will provide you support, but dealers know nothing, just how to sell and get money, nothing else. So we should figure out ourselves. Maybe it is somewhere in the user manual, but we are average users are lazy to read them. So yeah, and one more thing, guys, remember this discharge flow. Okay, well, I will explain. So I told you here that this number, remaining time, is probably related with the alarm that we set to 50%. And then when the state of charge is 50%, we get alarm. No. So, wait a moment. We then get remaining time 0. But I think I was wrong. I think that the real true value that this remaining time is based on is this one about discharge flow, which is also set on 50. I didn't change it, so I think it's that one. Again, if someone knows for sure, then let me know in comments, but I will probably later also educate myself more about this subject. But that is quite strange. State of charge 0. We didn't consume 33 that we set there as the capacity of the battery, and it's already state of the charge 0. We are still waiting for 10.5 here on the terminals of the battery. By the way, now the board is open. So we are waiting for that to see how many hours, and I think we will get at least 5 hours. So our math is more or less correct. Let's wait. 4 hours almost. And look what we have in 7 p.m. So 5 hours later, 5 hours, our estimated 5 hours, we still, so we consumed 33 amperes hours that we set there, but we still have 11.67 volts or 1175 on the terminals of the board. So I don't make any conclusions yet. We just still wait for 10.5 and then let's see. Well, guys, in almost 8 p.m. means 6 hours after our first starting of our discharging with this current, we see 40 amperes hours consumed with this current that we set 6.6 amperes. 6.6 multiply 6 hours, we will get around this amount of amperes hours. So 40 amperes hours, that's the true value that it gives us with this current, this battery. So well guys, let's do some conclusions. At the end we're still waiting for 10.5, but now the picture isn't set that clear. Well guys, something has happened quite quickly. I didn't notice this. I just come to look at this. Look, 6.8. Just 20 seconds ago it was about 8. And yeah, I don't know what has happened. And about half hour ago it was about 11. So we see this picture I just show you. I will quickly now disconnect it and we will start analyzing this, because it's quite strange picture right now. Okay guys, so 8 p.m. almost 9 p.m. so we got 44 amperes hours, but we missed the point of 10.5. We'll still see this inside, we'll still see this in the history, so I will check this soon. So I just show you the picture right now. So after 15 minutes I will analyze this, and let's see. 9 p.m. for 6 hours, and then I disconnected the battery. You have seen the previous state, and we have this voltage. And here is another piece of information included here, but it is for the later time. But it's just a piece of information in case if someone wants to analyze something. Is the previous cycle for this battery with recondition here, when we had recondition and provided about 71 amperes hours to the battery, and this is the current one, or actually we can say the second one that almost ended. It is in the float mode, but it will not provide a lot of amperes hours in the float mode, so we can say that 35 amperes hours we provided now. Yeah, so normal recondition, just an information in case if you will need to analyze something. It was a heavy cut just to show you the results on the screens of devices. However, I didn't like conclusions that I made. I will try to make it again. I brought this tablet PC. This one, by the way, I will review this later, but I can tell you in advance I more dislike than like it. So, but at least it has this big screen and we can see the history of discharge. And we will try to make some conclusions, but I'm pretty sure that you have to do your own conclusions based on the material I provide to you. Just let's take a look. So we started discharging at 14 here. So it's normal discharging, okay. We set 33 amperes hours, 100% capacity. And the next point that we were interested about it was half of the capacity when we should stop discharge. It happened at 17 volts in about just a couple hours. Not even 2 hours was enough for that. Yeah, but then we have seen quite strange things when the battery monitoring here shows 0, but the voltage is 1186 and it shows 0. It's set for 33 amperes hours, but shows 0, means that it should have consumed that amount. But when we look at the time, 5:40, it's about 6 hours and 6 multiply 6.6 amperes. We don't wait a moment, no, that's wrong. Wait a moment. Yeah, not 6, it's 3.5, almost 4 hours. And when you multiply the current 6.6, you don't get your 33 capacity, but about 26 or something like that. So I don't know why is that behavior, and I told you. So if you know, you can let me know in comments. I just provide you the information. I will make my own conclusions soon, And then, of course, we was expecting 10.5 this point, because it would mean that we should stop the test. It happened in 9:30, 8:30. It means that 6.5 hours after we started discharging, multiply 6.6 current, we have about 43 amperes hours in that battery instead of 30. Did I say 43 instead of 33? Yeah, probably after the recondition and desulfation it got more capacity again, I don't know. So, and then we started the charging. Yeah, so, but we are not so interested in this. So probably this part was a conclusion number 1. Probably I will put that time code. And now let's try conclusion number 2. I believe you have to make conclusion number 2 yourself based on what piece of information you take from this, because we covered a different subject. Maybe 2 main threads here was about how to test by the standard, how to test these batteries, and the second probably specific of the battery monitoring usage, specifically for this Victron Shunt. Yeah, and guys, I just share my use case. Probably it will be the same as yours, and what is my own conclusion for myself. Yeah, and why this all began, because I decided that from some point I want actually to monitor the health of my batteries in a better way than just by the voltmeter, especially when I bought that expensive battery, which is around $250 or euros, and I decided I need to have a better monitoring. And in my board I want to use the maximum capacity that I can get without damaging the battery. So I want to cut off them at 50% of usage, discharging, 50% of the capacity. And I don't want to have lithium in my board. Yeah, so that's why I put the shunt. But then, as you probably have seen in previous episodes, some strange things began. It shows just 90% capacity, but the battery is flat, 9 volts or something like that. Yeah, so, and I decided that I need to go deep to this subject. And my conclusion is, as you have seen from this information, this piece, a lot of information, that you cannot just take the old battery, set this capacity as 100% in the settings, and that's it. No, then 50% will be already maybe minus 20. Yeah, well, it's a joke, but something like that. And if you deal with old batteries, you constantly need to change what is the 100% for them in the settings of the shunt. And I'm not even sure that you can always I don't know how to explain it. Okay, let's forget about this. So you cannot just set it once and that's it. Probably you can do this for the new battery, the Optima battery, and actually in the next part we will test it. Yeah, we will test the new battery. Let's see. But it's not an ideal solution, but another solution doesn't exist. Yeah, so you just need to know the specific of operation, not even operation, but specific of how to use it. I think you have seen everything. It begins blah blah blah. So make your own conclusion. Let me know what piece of information you will take from that, what useful you found here, and subscribe to see the test of the new battery, either by C5 or C20. I think just one of them. I don't want to hear it multiple times. Bye.